Hi everybody, welcome to the demo, the show where companies come in and they show us their latest products and services. Today I'm joined by Brul Shah. He is the co-founder and CTO of Grey Matter Robotics. Welcome to the show, Brul.
Thank you, Keith.
So what are you showing us today? Because it's a robotic software platform, right?
Yes, it's a robotic software which allows the shop floor people to operate the robots as if they are operating a regular machine and taking all the complexities away for the smart automation being adopted in all this small to medium size enterprises which have been kind of away from automation just due to the complexity of it.
Yeah, and the big problem that you're addressing is a labor shortage for a lot of the tasks that the robot is doing, correct? Like
yes.
Grinding and sanding and some other processes, correct?
Yes, that is correct. In general, I think Grey Matter is focused on providing an AI platform for people to adopt robots in high-mix environments. Our early focus has been on process applications like sanding, polishing, buffing, grinding, coatings type application. We work with any industry from guitar makers to fighter jets. So we work with anyone and everyone in the space who requires to sand, polish, grind as part of the production line. The software, which is where most of the IP is paired with the off-the-shelf robot sensors and tools. And we deploy this whole solution to the customer for them to operate as a standard smart machine with their existing workforce to kind of augment them with this AI-enabled tools for them to do their daily operations.
And the big problem with a lot of parts that need to be sanded and or grinded or things like that is that a lot of them come in weird shapes. So if you had to program a robot to do this correctly, it would take way too long.
Days or weeks to do that.
Yeah, and
so one of the primary challenges why this ecosystem of industries have not adopted robots is what the industry refers to as high mix operation. So it's by high mix, it's the changes in geometries, changes in SKU size, changes in customizations which you add, as well as changes in material variabilities. So I would give you probably two examples in that space. Is one of them is, let's just say you are making a fire truck, right? When a city wants to buy a fire truck, depending upon what options they select, the design of the fire truck changes, right? And that happens on a day-to-day basis because no city would like to order a fleet of 25 fire trucks. Everyone would like to upgrade one by one depending upon what options they want to select. And even though fire truck is a high volume business, one of our customers who we work with, they have like 4-year backlogs in that, right? That is one end of the spectrum where the customization can lead to high mix. Another end of the spectrum is composite material. So even though you are making a fighter jet, which is the same fighter jet over and over again, and you would like to have that reliability because of the complexity of the environment which a fighter jet operates in, but the nature of composite is when you pull it out of a oven after baking it, the part will shrink and warp differently at different times. So even though to a human eye you think it's the same part, but when you kind of measure it, it is not.
Yeah.
So you have to adopt with all of those variabilities on the fly. And that is why both of these segments have never adopted automation. And with our scan and send solution, you are able to program the robot on the fly to work on all of these cues and geometries without knowing what you are going to work on that day.
And you were telling me earlier that the labor shortages, a lot of these companies that are trying to do a lot of these processes have like 3 to 4 year backlogs in some cases.
Yes, most customers who we work with have at least 2 years. Like most of them on an average have 3 years of backlog. And everyone is trying to figure out a way of how to be efficient as well as how to augment their workforce with smart robotic solutions which can assist them.
All right, so let's so stick around till the end of the video because we've got a surprise for you at the end of the video. But let's get into the demo, and this is a little different from normally. It would have been great to have a robot in here and doing all of this, but it was logistically impossible to do. So we've got you connected via Zoom to your facility in Southern California. We're out here in Boston. And so we're going to do this via a Zoom call, but you're controlling that robot, correct?
Yes, I'm controlling that robot, which is currently located in Los Angeles, California. There are a few people who are helping me with this. Christina, who is our marketing lead, and Rohin, who is our applications engineer as part of this demo. Christina, I think we will talk about the robot first. So I'll just briefly talk about the hardware before jumping into the software so that people get a context of what am I talking about. So if you see the yellow color piece of equipment is what a standard FANUC robot looks like, which is sitting on a rail, which allows the robot to slide across to work on multiple parts or large parts. And then you have a tool which is carried. Then you have a tool which is Krishna will focus on the tool.
Yep.
The robot is carrying the tool, which is a rotary sander with a abrasive or a sandpaper or a grinding discs,
Yep.
which you will have, and this is a rotary device. The box on the top, which is an active compliance device, which applies force when you are trying to remove material. And then you have a black box, which is a 3D scanner, which allows us to scan the environment as well as the workpiece which you want to work with.
Okay.
Most of our solutions have these package of tools, sensors, and robots itself, which we deploy for various applications. So if there is a new thing which we have added recently, which is not heavily marketed yet, is the tool changer. So on the left side of the robot, we have an ability to pick different tools. So in this particular demo, we would probably switch between two different medias, which will allow the robot to work on different operations on the same particular workpiece.
Okay.
I will talk a little bit about the workpiece now. So this is essentially, it will just feel like a box, but this is a very essential battery box. So every industrial equipment right now who wants to electrify, for example, a forklift. So a lot of shops are trying to get into electric forklift rather than CNG forklifts, needs to buy these boxes on which you construct a battery, which then gets installed onto the vehicle. So this is one of our customers who is using the robot in production, where you need to grind the welds of these boxes as well as scuff them up for painting operation before they ship this out to the customer.
Okay.
And they cannot take more business because they are already tapped out. They are running 3 shifts, 24/7, including weekends, and they cannot take more businesses out. So they have used our robot to improve their efficiencies as well as the throughput which they operate at. I would just like to show you the weld which is undone. Krishna, if you can focus on the input conditions of the weld which we will get, either on the front left or on the other boxes if you want to.
So how long would it take a regular sander, like a human, to kind of go and do all this? Because you do the robot, it helps speed up that process too, right?
Yeah.
Oh yeah, that looks pretty rough.
Yeah. So this is how the input conditions.
That's via Zoom.
This is how the input conditions of welds are. These are just sheet metals which are welded together, which you need to grind down and kind of prep it up well. Typically, a person takes around 20 minutes if you are a good operator to work on any of one of these boxes. Most times it's like around 30 minutes or so in a day. Which an operator takes to both grind and scuff this up.
Okay.
Overall. So yeah, this is overall what the setup looks like, and this is again at Grey Matter's facility. It's not a production facility. We deploy these solutions to the customer.
Okay.
This is just to host them and show them what the system are capable of doing it. Okay.
And you're going to show the software now?
Yes.
Yeah. Okay.
I'm gonna switch to the software. So this is what a scan and sand software looks like. This is what the operator sees. Overall, we have two different modes, a design mode and a process mode. A process mode is what is kind of like what the shop floor operator will use in their day-to-day runs. So what they do is when they select, saying that in this case it's a CIO demo run which we will be doing and I am the operator, where you confirm what you want to run, and then what you do is you click a scan and sand button, and then you just walk away doing something else on your floor. I would switch to what the robot is going to do. So in this case, after pressing the button, the robot has a scanner. It will scan the box in real time and compute where the box is placed, how it is placed, and then collect all the data. So this gives even the operator flexibility of not being precise in terms of placing the part. And also if you place a box which is of a size, in this particular, I think 18 inches in width, if you change the width to like 15 inches, the robot doesn't care because I'm scanning the part every single time. So this particular customer makes boxes for wide variety of end customers and use cases. And then that's why they love our solution, because you can put whatever in front of the robot you want. robot will scan and generate all the robot motions required.
Right. So you don't have, so the person putting that box onto the platform doesn't have to do it precisely.
Yes.
Which they may have had to in other manufacturing settings. So
Yep.
now it's changing the tool, correct? This
Yep.
is the tool changer.
So now it identified based upon the run which we want to do that we need to do a grinding operation. So it went and checked the tool. It was holding. It was a sanding tool. Now it will pick up a grinding disc. Once it picks up the grinding disc, in the back end, the AI software have finished computing all of the robot motions required. Once it verifies the toolet, it's going to go and start doing the grinding operation.
Okay, we're switching cameras just so that Christina doesn't get hurt. Okay, so now this is the grinding operation.
Yep.
Right?
So now the robot is going to reorient itself. So one of the challenges which we had is doing all the math of collision avoidance, tool contact point kinematics, the dynamics of how the tool is going to interact with the part. All of those operations were very compute intensive.
There we go.
And we can do all of these on an edge computer. It does not require a cloud. So even for customers who have working on a top secret programs, especially defense and DoD, can still use the technology where everything is computed local to the edge, and the cloud portion is just used for services and support if the operator needs to.
Do you think most customers would have this setup where they're operating this software in one location and the robots in another one, or is that just special because we're here? A lot of the clients are probably doing this on premise.
Yeah, it is.
Right?
It is special, but we have a version which you can use to support the shop floor operators, right? That way you can still use your workforce which is out there and have a suite of support members and teams which can support all of these smart units in an organization, right? So that way one engineer, even if you want to support as a DoD person, can support up to like 20 robots at a time, 25 robots at a time. You don't need to have them in South Carolina, for example, trying to be on the floor to support the systems.
Okay, was there anything else that we were going to show, or I think we're good?
So after this grinding operation, it is going to go ahead and switch the tool and then do a sanding operation after that. But we can talk about it.
And so just the surprise that we mentioned earlier is that you're offering people a free trial of the gray matter performance and quality, correct? Like, explain exactly what people can get so that they don't have to buy the software outright. They can see how good it is.
Yes. So we typically invite most of the customers to send their parts which they want us to work on, or a coupon of a part if the part is too big. Especially we cannot get a fire truck all the time. So a coupon of the part which you want to work at. And then we basically run this system as you are seeing in this demo, where we can place their part. We use our software and the tools. Engineers like Rohin would record a nice video for them of what the robot does on their part, as well as we use a suite of sensors to measure the quality. So we can also provide qualitatively what kind of metrics on the surfaces which the robot had done versus the people's operation. And then that way they can get an estimate of, okay, what would be the rough quality look like, what will the rough cycle time look like, all of that kind of stuff.
And switch over to the to that other video that you were showing me earlier before the show. You have that video of there was 4 boxes that the robot was doing, correct?
Yes. So typically in a production environment, the way we run the cells is...
Now this is obviously sped up.
Yeah, this is in a production environment. This is not part of the demo. I'm not running this robot. The operator loads up multiple boxes at a time. That way, with the one sweep of scan, you can kind of start working on multiple of these units in conjunctions. And you can see in the background, the person is outside the safety curtain. They're nowhere close to the robot. And they prep the rails with new SKUs which you want to get sanded. The person comes in, quick rotates the boxes, and presses go again, and then the robot goes and operates in this production. So we try to work with the customer to figure out how to batch and get most utilization out of the robot. That way you are not spending too much time loading, unloading, and doing non-value added operations, to keeping the utilization of these systems very high. That way you can get the most out of automation. Another thing for this particular customer, which they have also published a recording with us, they have had a 70% reduction in their abrasives. So people were prematurely using sandpapers and grinding medias just because the type of operation they were doing. With the help of robot, we are able to cut down that by like 70%, which almost from dollar value standpoint, it's almost like $200,000 a year, which itself pays
so
for
less,
the robot.
less wasted sandpaper then.
100%.
All right, Brule, there's a lot more I know that we can show in this show, but where can people go for more details on the software and the company?
Definitely, website is one of the primary things which we have some information on. YouTube.
It's just graymatterrobotics.com.
graymatter-robotics.com.
Okay.
We have a lot of content on YouTube. We have a lot of white papers for education for a lot of people who are wanting to get into these smart technologies and how to perceive AI for robotics, which is slightly different than AI for like ChatGPT or media, and how that, which we call to be physics-aware AI or embodied AI. And we have a lot of content for education in terms of when people are thinking about acquiring these solutions, what that would look like. And then definitely reach out to any of the team members, including myself, if they need more technical details.
All right, Brule Shah, thanks again. Thanks for the demo.
Yep. Thank you, Keith.
That's all the time we have for today's episode. Don't forget to like the video, share, subscribe to the channel, and add any thoughts you have below. Join us every week for new episodes of Demo. I'm Keith Shaw. Thanks for watching.